And good morning, everybody. These are going to be a few examples on finding the 5 remaining trig values if you know one of the trig values. The method I prefer is just to make a picture of the given information, and then once you have a completed picture, then you can find any trig ratio that you need. So let's look at a couple of examples that are in our textbook. Section 3.1, this is going to be number 18. So here is your given information. We know the sine ratio at some angle alpha has a ratio of 3 to 4. So if you remember your definition of a sine ratio, we know sine is y to r. So from this information, we're basically being told that the y value must be 3 when the r value is 4. The other piece of information you're going to need to know is what quadrant you're in. So we know sine can make a positive 3 to 4 sine ratio in either quadrant 1 or quadrant 2. So they're also going to need to tell you which quadrant it's in. So right here, they're saying that angle alpha is going to exist somewhere between pi over 2 and pi. So if we think of our circle, we know pi over 2 is at the top of the circle. And this is going to be pi. So they're essentially telling you that alpha has to be in quadrant 1. Or, sorry, quadrant 2, excuse me. So they're essentially telling you that alpha has to be somewhere in quadrant 2 between pi over 2 and pi. So now that we know the quadrant where alpha is, and we know the ratio, the sine ratio, we can go ahead and make a sketch and start finding the other 5 trig ratios. So if we sketch a circle, and what do we know? We're going to have some point that's on the circle. We know that the r value is 4, so that's going to be the radius. And we know this is going to be our right triangle. This would be the x that we don't know. The y value, they said that is going to be 3. So our y is 3, our r is 4. If we solve for x, we could make any of the trig ratios that we need. So we can use the Pythagorean theorem. We can say that we know that 3 squared plus the x squared must equal the hypotenuse, the 4 squared. And 3 squared should get us 9 plus x squared equals 16. And subtract 9 from both sides, so x squared should be 7. And then square root both sides, so plus or minus the square root of 7. So which one makes sense, the plus or the minus? So since we're in quadrant 2, x is going back to the left, so x is going to have to be the negative square root of 7. So that's going to be our x value. So let's put that into the picture. So we now know that x is going to be negative square root of 7. And now that we have all 3 sides of the triangle, we can make any of the trig ratios that we need. So they want the 5 remaining trig ratios. So we already know the sine at angle alpha. So again, angle alpha was the angle that was rotating from 0. So that was your angle alpha. It ended up in quadrant 2. We know the sine ratio is the 3 to 4, so now they just want us to make the other ratios. So let's make some room here, and then we can go make the other ratios. So if we know the sine ratio is 3 to 4, what would the cosine ratio be? So let's look at the cosine ratio at angle alpha. So cosine is x to r, so that's going to be negative radical 7 to 4. We could do the tangent ratio. So the tangent is y to x, so that's going to be 3 to negative square root of 7. And then you could rationalize that, multiply top and bottom by square root of 7. So it's going to be 3 square root of 7 all over 7, and it's going to be negative. You can give the negative to the top or the bottom, or just put it in the middle, so it needs to be negative since it was a negative down bottom. And then we could do our reciprocal ratios. So the reciprocal was sine, that should be cosecant. So if the sine ratio was 3 to 4, then the cosecant ratio should be the reciprocal, 4 to 3. Secant is the reciprocal with cosine. So if cosine was negative radical 7 over 4, then secant is going to be 4 divided by negative radical 7. And again, you can rationalize that, multiply top and bottom by radical 7. So that's going to be 4 radical 7 all over 7. And it was negative down bottom, so you need a negative somewhere in the fraction. It can be top, bottom, or right in the middle, wherever you choose to put it. And then cotangent is the reciprocal with tangent. So flip the one where you don't need to re-rationalize it. So if I flip this one, it's going to put the radical back down bottom. So let's actually flip the first one. So it's going to be negative radical 7 all over 3. And that is an example of finding all 5 trig functions when you know just one. So basically, if you know one trig ratio, you can find the other 5 because they're all located at the same point on the circle, which means they have essentially the same triangle, which means if you just finish your triangle, then you can find all the trig ratios that you need at that point. And here's one more example. This is question 22 from section 3.1. So it's given to us that cosecant is radical 3 to 1, if you want to make it look like a fraction, so radical 3 to 1. And that alpha is going to be between 0 and pi over 2, so that means alpha has to be in quadrant 1. And if we go ahead and make a sketch of this, so alpha is some angle, we don't know what it is, but we know alpha rotated into quadrant 1 somehow. And what are the facts given to us? It's given to us that cosecant is radical 3 to 1. So cosecant's the reciprocal with sine, so sine is y to r. So this must be r to y. So this is going to be your r. And this is going to be your y. So radical 3 is the r, and the y is going to be 1. So again, we need to go solve for the missing side. So x squared plus the 1 squared should get you radical 3 squared. So x squared, 1 squared is just going to be 1. Radical 3 squared, the square is going to undo the square root, so we're left with 3. And subtract 1 from both sides, so x squared will be 2. So x is going to be plus or minus the square root of 2. And which one makes sense for this particular x? It's in quadrant 1, so it's going to the right. So x is just going to be square root of 2. So that's going to go in for our x value. So we now know x is square root of 2. And now that we know all 3 sides, we can make all of the different trig ratios. So if we make the first one sine, the sine ratio is y to r, so it's going to be 1 to radical 3. And if you rationalize that, you should get radical 3 over 3. The cosine ratio at alpha, cosine is x to r, so it's going to be radical 2 to 3. Radical 2 to radical 3. Rationalize this by multiplying the top and bottom by radical 3. So once we simplify, radical 2 up top times radical 3 up top, that's going to be radical 6. And down bottom, radical 3 times radical 3 is going to get you 3. So there's the rationalized form. The next one, tangent. Tangent is y to x, so that's going to be 1 to radical 2. And again, rationalize that, multiply top and bottom by radical 2, so you're going to get radical 2 up top and a 2 down bottom. And then the reciprocals. So sine, we already have the reciprocal of sine, that was cosecant, that was given to us. So we need the reciprocal of cosine, which is secant. So we can take the cosine fraction and flip it. That's going to be radical 3 over radical 2. And if we rationalize this by multiplying top and bottom by radical 2, then we should get radical 6 up top and a 2 down bottom. And then cotangent. Cotangent is the reciprocal with tangent. So tangent was 1 over radical 2, so cotangent would be radical 2 over 1, which is just radical 2. And that should be your 5 remaining trig ratios for angle alpha at that particular location. And that is it for the examples from that problem set. So that's questions 18 and 22, and that goes along with the problem set section 3.1 in your book, numbers 17 to 22.